Algebra 1 students, in this video we're going to show you how to simplify some radicals, and we're also going to show you how to rationalize the denominator. Alright, so some of you might already be noticing that this is the same thing as your worksheet and not a new set of notes. Mr. Bear, you're getting lazy. Maybe, but let's go ahead and do this. Here we go. Number 1, it says the square root of 24. Now, before we really get started, I want to go over a little bit of vocabulary with you again. There is an index, okay, in every radical. This would be the radical. We'll call that the radical. And then we have the radicand. I can. Okay, so these are the different aspects of, a radical, and these are some different vocabulary that you need to understand when we're dealing with radicals. Okay, so right now we are dealing with radical 24, and so what I'm going to do to start off with is I'm going to look for perfect squares that are embedded within the radicand. In other words, that number that's sitting right there. Okay, so I'm looking for a perfect square that's embedded within that 24, and I immediately notice that 24, 24 has a factor, it is a factor of 4, so I can multiply 4 times 6 and get 24, so 4 times 6 is equal to 24, so I can say that those two things are equivalent. All right, and then I could break this down a little bit further and say, okay, well, that's equal to radical 4, radical 6. And some of you might be saying, okay, why are you going through all that trouble to break it down that much? Well, if I don't break it down this far, a lot of you don't realize what happens in this next step, because I'm going to go beneath that here to show you what happens. That radical 4 is equal to 2. Now, radical 6, okay, is equal to 2 times 3. Yes, I could break that down a little further, but it doesn't do me any good at all. And so that's just a waste of time. Not going to deal with it. So, the simplified version of the square root of 24, or radical 24, is 2 radical 6. All right, we are going to skip down here to number 4, all right, because that one has a coefficient, and I think that one's going to trip some of you up. So we need to discuss some of the things that occur in math that are invisible. This problem, has some stuff that's invisible. So I'm just going to rewrite this as negative 4 multiplied by the radical of 175. And I hope that that helps you. Okay, because there is an invisible multiplication symbol between a lot of stuff in math. Now, if it helps you, some of you might need to go ahead and on the margin of your paper, just go ahead and write down all of your perfect squares. 1 times 1 would be 1, 2 times 2 would be 4, 3 times 3 would be 9, 4 times 4 would be 16, and 5 times 5 would be 25. Some of you might need to go all the way to like 13 or so, I don't know, maybe 15. But if you know your perfect squares, which is why we were working on them in class a couple weeks ago, if you know your perfect squares, and you find your perfect squares within the radicand, it makes your life better, I promise you. So let's go ahead and take this 175 and break that down into 25 multiplied by 7. All right, because if I had 7 quarters, I would have a $1.75. That's the way my brain thinks. It's always thinking about money. I guess I don't know. Here we go. I'm just going to rewrite that as negative 4 multiplied by the square root of 25 multiplied by the square root of 7. I'm just going to rewrite my radical as such. So now I can take this radical of 25. I'm going to go ahead and simplify that to be 5, because 5 times 5 is 25. But when I write it in my expression here, I'm just going to put it inside of parentheses like that, so that it's clearly indicated that there is multiplication going on between this negative 4 and this 5, and we're pretty good with this by now. We know that that's negative 20, and it's still multiplied by the radical of 7. And so this right here would be considered simplified. All right, let's jump to number 7. Number 7, I notice a perfect square that's embedded within this radicand coefficient of 32. It is 16. 16 times 2 would be equal to 32. And I also notice a perfect square that's embedded within p to the third. It's p squared. And I'm just going to break that radicand down like that. All right? Because I notice, and let's change colors here. I notice that I have a perfect square there, and I have a perfect square there. Those things can come out of my radical. So I would have 4, because 4 times 4 is 16. P, because p times p is p squared. All right, on the outside of my radical, I still have an invisible 2, by the way, right there in my index. We don't usually write that invisible 2, okay? But I've got a 2p in my radical. Those two things had to stay inside of my radical because I couldn't simplify them or get them out of there. All right, so let's jump down here to number 9. All right, something that you can do when you multiply radicals is you can take this radicand and put them under the exact same radical. I can do that right there. All right, so when I do that, I end up with radical 20. And the reason why that helps us in this case is because radical 20 is equal to radical 4 times 5, or radical 4 times radical 5. All right, and I can rewrite this or simplify this as 2 radical 5. Hopefully that helps. All right, I know some of you were sitting there looking at number 11 and thinking, I really hope that he shows us how to do that one. Well, sort of is a funny word, sort of. I am going to sort of show you how to do that one by getting you started, but then I'm going to leave you hanging because your answer is in the answer key, and it keeps disappearing on me. Stop disappearing. Okay, so I've got negative 2 multiplied with 4 multiplied by radical 3 times 15. And I'm going to leave you hanging right there and let you finish that problem. All right, next we're going to jump over to this practice rationalizing the denominator worksheet. All right, and if you haven't said this out loud right now, I want you to say this out loud. Go ahead, practice rationalizing the denominator. All right, so here is the trick to rationalizing the denominator. I can multiply anything. By 1, and I will get the exact same thing. So if I multiply by a version of 1, it is actually a trick that will make the radical in the denominator go away. Watch what happens. I'm multiplying by 1. I've got radical 3 over radical 3. So my numerator is going to end up being, I'm going to turn down the volume on those ads for advertisements. My numerator is going to end up being 4 radical 3. My denominator is going to be radical 3 multiplied by radical 3. Well, that ends up being radical 9, because I can go ahead and put both of these radicands together under the same radical, so I end up with radical 9, and that ends up being 3. So I end up with 4 radical 3 over 3. Notice how my answer, that's my answer by the way, notice how my answer has no radical in the denominator, and that's why we call it radical. Okay, so we're going to go ahead and skip down to number 6. All right. On number 6, I do not need to multiply by that coefficient in order to get rid of this radical. Okay. So what I'm going to do is I'm going to multiply by 1 still. So I'm going to multiply by the square root of 15, or radical 15. When I do that, a couple of interesting things are going to occur on this problem. All right. So 12 times 15 is 180, so I'm going to end up with the square root of 180 in my numerator. these radicals, I hope you have figured out by some of your practice now that these radicals kind of cancel out. So I've got 3 times 15 in my denominator, or radical 180 over 45. Okay, I'm going to use 36 is a perfect square that goes evenly into 180, or it goes nicely into 180. So I've got the radical of 36 multiplied by, let's see, I did that just a second ago so that I wouldn't have to do that on the video. 36 multiplied by 5 is equal to 180, and I've got 45 in my denominator. All right, so I can go ahead and simplify radical 36. That's going to be 6. Radical 5 is still going to be inside of the radical, and I've got a 45 down here. And 45, let's see if that's divisible by 6. Divided by 6. 45 divided by 6 is 7.5. Let's see, there's got to be another way that I can reduce this. So 45, let's see, divided by 3. That works. So I could reduce this by 3's. So I'm going to go ahead and divide 6 by 3, and I would get 2. When I divide 45 by 3, I get 15. I don't believe I can reduce that any further. I believe I am done. I'm going to leave that as my, what we call, exact answer. And folks, there you have it. That is how you rationalize the denominator. Rationalizing the denominator.